The library generation engine is used to create and modify a cell library database of power grid views. In an integrated circuit design, it is common for many standard cells and megacells to be reused across multiple designs. Cadence flows require you to pre-process such cells, reducing the overall time required for extraction. Power grid view generation is essentially carried out in two steps. First, in the physical implementation, layout and physical files are read in and converted into a power grid database. While for electrical characterization, netlist and SPICE models are converted into an equivalent RC network. Voltus analysis uses power grid views to define the electrical characteristics of blocks of a design. These power grid views contain resistor, capacitance, and current information, which is used to model the block for power grid analysis. The PGVs are characterized with port geometry, interface nodes, power grid RNCs, device capacitance, and device current. The most accurate power grid view is the one which contains extracted resistance down to the transistors of the block. Other views, such as the abstract view, can be used to speed up the top-level static analysis with no loss of accuracy. This section discusses various abstraction levels or the details about the power grid view types. The tech view is a basic view generated in the technology library for every cell. It only contains the current distribution factor and decoupling capacitance at the power port of the cell. The early view is used for a standard cell and macros. It contains only the current distribution factor and SPICE simulated decoupling capacitance at the power ports of the cell. It doesn't include the parasitics associated with the interconnects, which prevents IR drop in the block or cell from being analyzed. Early power grid view is the default for rail analysis in the accelerated definition or the XD mode. The IR view performs a reduction on extracted power grid for macros. It merges small current value current taps together, without significant impact on accuracy. It does result in high performance because of the reduced data size. For standard cells, since there is no internal power grid, the IR view is the same as early view. The capacitance is calculated based on simulation, and attached to each power port along with the current taps at the center. Now, coming to the EM view. For macros, it contains the extracted power grid from the GDS2 data of the cell. GDS2 and XY SPICE netlist is required to generate the accurate current distribution and decoupling capacitance. It creates current taps on the bottom conducting layer, at the location of the vias layer above it. The rightmost arrow shows different view types and the accuracy level. As we can see, the EM view is the most accurate since it contains a detailed RC network information. Choice of view also depends on the accuracy required, type of cell whether it's a standard cell or a macro, design stage whether the early form of the design where early or IR view can be sufficient, or at the final sign-off stage where EM view is a must.